Welcome to another episode of the Untangling Web3 podcast. Today, we have the pleasure of welcoming Dr. Keir Finlow-Bates, a renowned blockchain researcher, prolific inventor with over 40 patents, and the author of Move Over Brokers, Here Comes the Blockchain. With an MA from Cambridge and a PhD from London South Bank University, Keir brings a wealth of knowledge and a touch of humor to the complex world of blockchain. Today, we will be discussing smart contracts, so get ready for an enlightening and hopefully entertaining discussion with one of the leading voices in blockchain technology.
Well, thank you very much. It's nice to be here.
Yeah, I was really excited to have you on. I saw you, all over social media on LinkedIn. I think the first thing that I saw was you walking through, your garden, which is in the woods in the middle of Finland with a snowy backdrop, talking about blockchain. And one of the first captions that came up was blockchain Gandalf. And I was like, who is this guy? We need to have him on the podcast. Like, this is someone I want to talk to immediately. So I'm really excited to have you on.
Well, it's really nice to be here, and it's not my back garden. It's actually the Finnish wilds. It's proper forest.
Okay.
Yeah, I've actually been watching your videos, for about as long as I can remember them being out, to be honest. I feel like it was during the pandemic years, and it was really nice because you were about the only person going out every day and wandering through the woods, and enjoying it. But actually, I found the videos really, really interesting. The way you not just talking about the technology, but talking about the societal implications and, just getting a nice kind of I guess a layman's perspective on it as well, because obviously you're not a layman, you're very deep into the technology, but you the way it comes across when you talk is, I think, is exactly what we need in the industry. So I think we should really spend some time getting into the kind of the nitty gritty of what are smart contracts and contracts generally. So let's start there before we get into the smart version. How would you define contracts as a concept overall?
Well, I think that's actually where the original problem starts, right? Because a contract is a legal concept. And there are some pretty good definitions out there that it's an agreement, a binding agreement between two parties. In most jurisdictions, there has to be something called consideration, which means that you're paying something or providing something, and you're getting something in return. And ultimately, a legal contract is enforceable through a court. So when you have the term smart contract, it triggers a thought of what we all feel a contract is about. Everyone's signed a contract at some point in their life. Most people in entrepreneurship have signed hundreds. And that, I think, leads you down the garden path, because it's not about encoding the law in software. It's about something slightly different.
Okay, yeah, because I think that's one of the things most people tend to maybe get wrong, right? Is that they go down the coder's law. How do we put the law into code? And obviously, when you do that, it's very hard to account for all the edge cases, right? That's why we have lawyers. That's why we have such a long and detailed legal process for lots of things, because it's very difficult to get to the ground truth of things. So what is that alternative model then? What do you think we should mean when people start talking about smart contracts?
Right. So rather than trying to encapsulate something that may well be subjective, right? Have you done the job well enough, or are the goods satisfactory? With a smart contract, it really is just about deterministically moving value around. That's what it boils down to at its core. A smart contract is a small computer program, and they are typically very short by computer programming standards. A long one might only be 600 lines, which anybody who's a programmer will know is nothing. Typically, companies that produce software are looking at hundreds of thousands of lines of code. So they're small, and because they're running on a blockchain, and the blockchain creates these tokens which we ascribe value to, those programs can decide under what circumstances and what conditions the tokens get moved from one party to another. So it's kind of more like automated banking in a way than it is about the legal aspects.
I like that. I actually really appreciate that. I remember like seeing when this kind of smart contracts was the buzzword and everyone talking
Mhm.
about it and saying, the entire legal field is going to disappear and smart contracts will replace everything. And what you're kind of saying there, and something I definitely agree with, is that actually what smart contracts can do is a real subset of the overall
Mm.
contract space. It's very simple, I imagine, quite
Mhm.
narrow field, like very transactional. And there's so much nuance in law, as we know. I actually really dislike the nuance. I think most people do. But you're
Yeah.
saying the nuance has to be there for so many reasons, and smart contracts won't replace all of contracts. It's just the simplistic, deterministic things.
Yes, it really boils down. I mean, that's the first thing, and we can talk about other things you can do with smart contracts further on in the program. But to start with, it all kind of builds on this fact that blockchains are creating these digital tokens or cryptocurrencies that have a real dollar or pound or euro price attached to them. And then you start thinking, well, what can I do with those digital tokens? How do I set out the circumstances under which I'm going to move them around? And of course, maybe we could take a step back and talk about Bitcoin briefly, right? So there you have the first blockchain. It creates these things called Bitcoins. There can only be 21 million of them. At the moment, I think they're priced at about $65,000 a Bitcoin. But they're created by a computer program that's running on lots and lots of machines at the same time. And that gives a programmer a really unique opportunity. If I want to write some software that moves pounds around or moves dollars around, I have to possibly get a banking license. I may have to sign up with a payment processor like Stripe or PayPal. I'll need to learn about banking APIs. They're all different from bank to bank. And I need to get these institutions to agree to allow me to do what it is I want to do with their service. So my local bank here is not going to be very happy if I say I want to start moving euros from bank account to bank account using code. That might make them feel a bit edgy. But with blockchain, it's out there. It's open source. It's open. It's permissionless. Anybody can run a Bitcoin node. And so if you're a programmer and you're running a Bitcoin node, there's an API that allows you to send commands to the node to spend Bitcoins that are in your address, in your wallet.
Mm.
But the issue there is that you're writing an external program to do that. So I can run a Bitcoin node, I can write a piece of software that runs on my computer and that looks out for things happening on the Bitcoin ledger and reacts to them and does stuff. But it's just my computer that's doing it. So the big step that Ethereum, the first smart contract platform, took was saying, well, what if those applications that Bitcoin developers are writing were actually put on the blockchain as well? Then everybody can see them. And then you have some transparency where I can write a piece of computer code that says, under these circumstances, this value will move like this. And everybody else can check that that's indeed the case. And that, I think, is the sort of the initial origins behind the idea of smart contracts. But then it gets a lot more complicated.
Well, I hope we go into some of it, but thanks that the step
Mhm.
back really does help. That it kind of sounds like you're saying we really needed the blockchains, Bitcoin laying the foundation, then Ethereum
Mhm.
taking it one step further to really push this agenda. And I think one thing you mentioned there was the idea of institutions in banking. Traditionally, Bitcoin really tried to remove some of those unnecessary intermediaries, and that's one of
Mhm.
the things that's often pushed around the concept of smart contracts.
Mhm.
Is it's that you remove the need for intermediaries. Do you actually kind of prescribe to that fact? Do you agree with that fact? Because it sounds like we're kind of offsetting the intermediaries to coders, potentially the network itself. What do you think about
Right.
that?
Yeah. So that was kind of the first generation interpretation of blockchain, was that it was going to remove brokers, intermediaries, platforms, and actually put control in the hands of individuals again. And it hasn't quite panned out like that, because there's a very small group of people who can just do it themselves, right? And as the systems have become more complex, it becomes even harder for everybody. And even as an experienced developer, I can't code stuff on Polkadot. I haven't spent time at it. I don't mess around on Solana. I'm very niche. for me, it's Bitcoin and Ethereum. And like everything, as time goes on, the field expands, and suddenly more about less and less until eventually you know everything about nothing. And that's the way blockchain's been going.
Yeah, it can often feel like that doing this podcast, to be honest. You speak to lots of different people about different blockchains, and you suddenly realize how much you actually don't know about how lots of them work. And yeah, I think we're
Right.
quite similar, actually. We use Bitcoin and Ethereum as our jumping off points, right, for understanding the general UTXO type blockchain versus account-based EVM style blockchain. While we're taking this step back, because I think I'm really glad you did that as well. That was, we don't want to put the cart before the horse here. Do you think then blockchain is a prerequisite to what we're calling like a meaningful smart contract? Do you think there would have been any other way to achieve what people are doing with smart contracts now if we didn't have a fundamental layer like blockchain? Or, what are the distinct properties of blockchain over anything that came before, do you think?
Well, in a sense, smart contracts already existed in databases. In databases, they're called hooks. So you have a database with data in it, and a hook is a piece of code that will do something with that data when the conditions are the way it needs them to be. Database developers hate hooks because they open your database up to lots of vulnerabilities, and you have to check the code very carefully, because if a hook gets triggered in a circumstance that you hadn't predicted, you could end up with data corruption or a hacker exfiltrating the data. But in a sense, database hooks very, very similar to smart contracts on blockchains. But the big difference is that a database is a private thing. You have to have permission to use it, and your typical database doesn't instantiate value. And that is, and there we're moving out of technology and into psychology and sociology, right? It's why are people ascribing value to these things on the blockchain? And it's a very difficult question to answer. Why do we ascribe value to money, right? It's the kind of question you're asking. You're digging into that aspect of humanity. But as a developer, it's very easy, because you just say, I don't really care. The fact is that Ether has this value, and Bitcoin has this value, and I can use them as building blocks in my software, except that they have this great extra property, which is people are willing to pay for them. And so that's one of the things that I found very appealing, even back when Bitcoin was just a couple of dollars. The fact is, it felt like you were writing code that was moving money around as if you were running your own stock market or your own commodities market or your own bank. And that was one of the early slogans for Bitcoin: be your own bank. Right.
I really like that. I think that the kind of smart contracts kind of implies a lot of things. And I've had a lot of people come to me and be like, what's so smart about these contracts? Like, do they do intelligent things on their own? Are they fully autonomous? All these kind of things, especially with the AI bubble as well. It gets really weird, some of the questions I get. And I remember my last place, we started to call them just automated programs. That's it. They're just automated programs that are hosted on a blockchain. The two main differences between them and like normal code is, like you said, one is you can have intangible value being executed there. And the other thing is that they're distributed, they're open, anyone can kind of access them. And I think that kind of helped with the definition of people's understanding a little bit. So you've kind of talked a little bit about, the idea of contracts and then them being hosted on an open distributed platform. And that's what blockchains did, right? Could you take us through, the more depth into how they actually work? Then you talked about value exchange and all this kind of stuff, just at a high level.
Right. Okay. So let's stick with Ethereum then. So out there we have, God, I don't even know the number now, probably in the tens of thousands of computers that are all running the same, well, not necessarily the same software, but the same protocol encoded in software. And there are a few versions. We don't want it all to be the same software, because if there's a mistake in one, it's good to have different versions of the same thing. I suppose that's a bit like us having Apple and Windows and Linux, right? If one of them has a disastrous security incident, I'm not thinking of anything recent here, at least you have two other platforms that are still running, and the whole world doesn't collapse because of one badly pushed out software update, right? But they're all running the same protocol. They're all speaking to each other in the same language, even if their brains are different. And they're all synchronizing a kind of massive global ledger. which from a programmer's perspective, you can kind of think of as a database. It's storing data, it stores it in a particular structure, and a subset of that data is this native cryptocurrency, which for Ethereum is Ether. So there's God knows how many millions of Ethers out there, and it's recorded who owns what amount of Ether. So that's again like society. We all have records of how much money we own, and it's locked down because everybody's watching and because everybody's agreeing on how the data can be updated. You can't sneak in and up your bank balance by 1,000 Ether, because everybody else is looking and saying, no, that's against the rules. We'll discard that attempt, which is a problem that the solution that the banking industry doesn't have. In banking, we have lots of auditing. And there are like amusing in quotes cases where I think there was an Indian bank that was messing around with international transfers and creating money out of thin air. And they were doing it in such an obfuscated way. It took years for them to get caught because it's not transparent in the international banking system. You're relying on auditing to make sure that everything's done properly. So you've got this big ledger saying who owns what. It's all stored in data. The data gets changed according to a set of rules that everybody agrees to. And so what you really have is tens of thousands of computers all running the same code to get the same result. And then you know that you have a single view of the truth. So that view may include me having 1 Ether and Jack having 2 and Alec having 3. And then Alec decides to transfer 1 to me. If it's a valid transaction, they all pick that up, include it in the database, which is called a blockchain because it's a chain of blocks of data. And now we have an updated new single view of the world where I have 1 more ETH and Alex has 1 less. And in a sense, it's as simple as that. It's kind of like us all sitting around in a circle trading with everybody watching the trading. So at the end, we know that everything was done fairly.
I really like that description. I think that's much better job than we ever did describing blockchain. So thank you for that. And I did expect that you would kind of school us on this. So sticking with that and taking it one step further, then you described in this kind of database that is the blockchain, you have these entities or accounts or entries where you said, we have money associated with them. You can debit, credit, that updates the state of that database. So in my mind, one of the things that Ethereum did, because you mentioned it's a smart contract platform, right? Which is a differentiation and an evolution from what Bitcoin was really, because you only had kind of restrictive options.
Very limited scripts. You can hardly do anything with Bitcoin scripts.
Yeah. And I think one way I like to frame this is about people call smart contracts first-class citizens. So in that database, the entry could be essentially a person like you or I. So it's effectively my account of my money. But then you can also have these smart contract accounts. So they become their own entities. So would you be able to describe like how does that work then? How does a smart contract become an entity? How do people interact with them, right? What does it mean for it to be a first-class citizen in the blockchain world?
Well, you're right. In a sense, the smart contracts are like the sort of when you have the concept of legal persons in law. So like a company is treated as a person. And in the smart contract world, a smart contract is treated like a person, like you or I. And the way that works is that your identity on the blockchain is through your blockchain address. And that is like your bank account number on the blockchain, except unlike a bank account number, you can create them yourself, as many as you like. So that kind of goes back to the being your own bank. And it uses something called asymmetric key cryptography or public-private key cryptography. You create a private key that only you know. You derive a public key from that. And then you derive the blockchain address, your account number on the blockchain from that. And then when you own stuff, it's registered against that account number in the same way that when you have a bank account, your balance is recorded against your bank account number. So that's all great. And we could briefly touch on the fact that because you have the private key, you can digitally sign the transactions, and that gives you the authority to make decisions or submit transactions that only relate to your blockchain account. The neat thing with Ethereum is when you create a smart contract, it's also given its own account number. And so from the outside looking in, you can't tell by looking at an Ethereum address whether it's a person with a private key who is signing transactions or whether it's an address that's associated with a smart contract. So from a technical point of view, as far as the system is concerned, it's an account number, and it doesn't, in one sense, it doesn't really care whether it's a person or whether it's a computer program that is controlling the assets that belong to that account number.
I guess one differentiator between, say, an individual account holder on Ethereum and a smart contract on Ethereum is that the smart contracts can't generate transactions themselves, right? They only relay transactions, which I guess is one differentiator at a high level. We've kind of,
Absolutely.
I guess we've talked about a little bit about what smart contracts can't do, that they're very niche within a niche of the general contracting landscape. But aside from transparency, why is there so much hype around them? What are some of the advantages the smart contracts, based on blockchain technology, actually bring to society?
Okay, so still sticking with the money side of things, if you think about financial innovation, right? We have things like direct debits or standing orders. When they first came out, the idea that I could pay my magazine subscription in an automated way by saying every month, keep paying that publishing company this sum of money, and then they send me the magazine that I want, and I don't have to think about it anymore. That was at the time quite a revolutionary idea for finance, that you don't have to remember to do the payment every month. It's automated. So what smart contracts can do is they can do that kind of thing, but massively powered up. So it's not just a recurring monthly payment. You can write programs to do all sorts of weird, complicated things. You can say, well, it's going to do the payment every month unless something else happens. Like somebody else, I can write a program that says, pay this account every month, this amount, unless that account has a balance of 0, which means they've taken all the money out of it, then stop paying on the assumption that maybe it's been hacked, right? So that now you've got something that's like a 2-step standing order. And you can layer it as deep as you like, right? You can write programs that will allow the value to be moved around in much more complicated manners with many more inputs and many more actions than just something as simple as a direct debit. So that's just the start. One of the things we should talk about fairly soon is the way that you can write data in smart contracts to the blockchain and put conditions under which it can be changed and retrieve it, because then we can start talking about how you can actually create your own tokens, create NFTs, have whitelists where you say who can use the program and who can't, under what circumstances, things like that. So as a developer and an inventor, I find it fantastic because I can just sit down and start thinking up possible things that you could do with them. And I've submitted inventions in the fields of Wi-Fi, of satellite navigation, databases, security. I've just found blockchain and particularly smart contracts to be the most fruitful area to be inventing stuff. It's so new that you can come along and do some pretty amazing things.
Yeah, I think because we're talking about these as smart contract platforms, they have been pitched as very general purpose, and I think that's true. Pretty much anything you can think of an application for a smart contract, right? You have these kind of these distributed, decentralized marketplaces, peer-to-peer lending of things like energy. I've seen talked about a lot. So I 100% agree that the expressiveness you get with smart contracts now in Ethereum-like systems, as opposed to what you have in Bitcoin, is basically opening up all these possibilities, right? And you even now have because of the fact that smart contracts can communicate with one another, and they have all the things you'd expect from normal programming languages like inheritance, so they can inherit from other contracts. You can have these incredibly complex things, from which I think we have DeFi now, right? DeFi is what people refer to as this very complex kind of miasma of different things, and that might also come with some pitfalls. What is your take on using smart contracts for what people call DeFi at the minute?
Well, it's the first thing it did was make me realize that a lot of what is going on in conventional finance does look a bit like a game of Monopoly from the outside, right? So, because I came into a lot of conventional finance through decentralized finance, and you sort of see it and go, this appears to be people trading stuff that they've made up themselves, and some of them are making profits off of them, and some aren't, but it looks a bit like a game or gambling or something like that. And then you start digging into how, for example, commodities trading with futures and options work. And you start realizing that this kind of stuff is going on in conventional finance as well. And in fact, a lot of finance has become so disconnected from the original thing that it was meant to be involved with, that it has become a bit of a game. I mean, the classic example is a futures trader on the Chicago Mercantile who was known for being an expert green lumber trader. Was making a lot of profits, and somebody asked him one day, "What is green lumber?" And he said, "I don't know, some kind of wood that's painted green." Right? And the guy had spent his life trading this thing, but he didn't care what it was, right? He just knew how it behaved from a financial perspective, and he understood, how to trade it to make a profit. And as far as he was concerned, it didn't matter whether it was freshly cut trees or whether it was frozen orange juice or oil. It just happened to be a particular market he's familiar with. And so when you look at DeFi, you're going to get the same kind of feeling, which is, what is going on here? What's the... But it is starting to get more tied to real world cases and moving out of this game. And part of that is because it allows you to mimic a lot of the financial instruments that we have in traditional finance. And you're doing it in a way that is opening that up to more people, and that allows for more expressiveness again. So, if you're stuck with just futures and options, well, that's not, well, with smart contracts, you could code up a contract that emulates futures with extra functionality. If you wanted to, you could have futures that cannot be traded on prime number dates, if you really wanted to. I don't know why that would be useful, but you could do it. You can't do that in the traditional financial world, because there's no programming language to support it. You'd have to convince everybody that that's how we're now going to behave. Now, as I said, that was just a silly example, because I don't think off the top of my head there is a use case for futures trading that cannot be done on dates that are prime numbers. But maybe there are some other things that some conditions that you are of concern. It's like automatic shutdown if there's a price collapse, for example, things like that. So
yeah, that makes sense. I mean, when we did an episode on DeFi, and we kind of understood most of the concepts. Well, to a high level, we understood most of the concepts in DeFi. Then we tried to, we were like, okay, to really do this properly, we have to do an episode on TradFi. And that got so messy. We were like, I have no idea what half these terms, how half this stuff works, how it's legal. It was a really, really messy episode overall. I felt more confused by the end of it than I did by the start.
I can imagine it. I mean, I actually joined a project for nearly a year involved with trying to automate trading, just to learn about what is going on with these things. What is a put? What is the difference between an option and a future? What is a derivative? What is a synthetic? And you're just, as an outsider, you just end up feeling baffled and think, this is bizarre. And it's not just the fact that the terms are complicated. It's a historic system. Some of these things have grown over centuries, and as a result, there's like years of human history behind them and quirks to it that do not actually make rational sense at this point in time anymore. So.
Yeah, it is bonkers. I remember seeing an interview. I'm not going to quote who it was by exactly. It was someone really high up in the Fed in America, and the interviewer question was something along the lines of, "Why does America print money and then loan the money back to itself and then charge interest on the money it loans back to itself? And the guy couldn't answer. And it was, I don't know how much of it was fake or real, but he was like the head of the Fed. And it was just like, it went everywhere with Bitcoin. Obviously, all the Bitcoin fanboys were all over it. We could talk, I spent a whole episode talking about some of the shortfalls of fiat and TradFi and all this stuff. But so back to smart contracts. We talked a little bit about misconceptions, maybe limitations of smart contracts when you kind of talk about the big picture and what some people think they can do versus what they actually can do. What are some of the other misconceptions in your mind? Like we talked a little bit about, they're very deterministic. They don't always cover the gray area. There's a lot of jargon around this stuff. Could you talk about some of the other limitations in your mind?
So I'm trying to think now. I've kind of gone a bit blank. I think the biggest one actually is that the smart contract can really only read what is on the blockchain, right? So this touches on oracles, which is, it's all great if you're trading tokens that are all instantiated on the same blockchain, and then the contract knows exactly who has what and what its relative value is. So if we all create our own tokens and we all list them on a decentralized exchange smart contract, that contract has access to all the data it needs. When you start trying to bring in real world stuff, then you start hitting problems because you need oracles, you need trusted entities to put the data on the chain for you. And then you have two problems, well, three. So one is a delay in getting the real-time data onto a chain when you may have to wait 12 seconds for each block to come along. The second is there's going to be a cost associated with that. So now you're paying for your data. Although, I mean, I believe Bloomberg terminals are not exactly cheap. So maybe it's not a fair complaint to level at oracles. And then, the third thing is trustworthiness. When there are potentially billions at stake, if you have an oracle, well, the whole thing about blockchain is that you incentivize people to be honest because they make more rewards through the incentive scheme by following the rules than they get by breaking them. But when you have an oracle, you may end up in a situation where the company running it could make more money by lying about some data and taking advantage of that lie than actually being accurate. So, that's I think a really key example.
I think the term garbage in, garbage out kind of comes to mind as people tend to use a blockchain, and like the holy grail everyone's been pushing is that IoT is going to solve all the problems. And I'm not sure we're any closer to that, but it's a nice vision anyway.
Yeah, I mean, it's just like they say, okay, we'll put these sensors in this van and then we can tell whether it went above freezing and the stuff inside is spoiled. But anybody who knows anything about computer security will tell you it'll get hacked. It's not just a question. It's not a question of if. It's always a question of when.
Yeah, exactly. I mean, speaking of hacks, and you're also, I think, touching there on this whole idea of on-chain data, right? Putting raw data as well on the blockchain, which there are various potential applications for. Like the simplest case would be something like if you are creating an NFT, a token, where you have a JPEG associated use case for an NFT, the simplest one, then we've had these things in the past where because of those costs of putting the image on chain, people will put a URL to an external source and then the image disappears or it changes over time, that kind of thing. So that's one motivation for why someone would want to put data on chain, right? Just to preserve my NFT. Because you were mentioning it earlier, do you have any other views on that? Do you think there are good use cases for putting data on chain for other things? So, aside from oracles for things like price, do you think there's any application for the immutability of data on the blockchain, even just for persistence of data and things like that?
Well, I have to think it's very good for storing and then retrieving data. I mean, in that sense, it works as a public database. I can write a smart contract. I can create data structures for that smart contract, and then I can fill them in as and when needed, and then other people can read them. And if I need to hide it from the world in general, then I can encrypt it. Of course, you have to be careful because just because it's safely encrypted now doesn't mean it will be in the future. So you have to assume that eventually it's going to be readable. But what you can do is you can put data on that in the short term. It's fine if it's not readable and then later becomes readable. You end up with all sorts of great things that you can build if you have a public store of data where the changes to the data have to be clearly defined and everybody can see what the requirements are for those changes. So that's why it's so good for registering ownership, for example. I think it's going to play a big part in identity, that having an identity on the blockchain is a good use. And then you can set access management stuff then as well. I can create a system whereby you can only call a function in my smart contract if you own a particular NFT. And then I can have a limited set of people who are allowed to use my contract because they are the set of people who have the NFTs and the rest of the world doesn't. And then maybe if that's a smart contract that people want to interact with, well, then your NFTs will get more valuable. So now we're getting to a more sophisticated version of smart contracts where the underlying system is the same. It's still code and it's still running on all these nodes, but we have value to move around, and now we have perceived value of things that you and I can create on it. And when you think about it, that's quite amazing. That I can launch a contract, instantiate these tokens through a data structure, and then somehow they pick up value because they become desirable.
Yeah, I think I'm glad you're also a proponent of that idea. I think I certainly am, and Alec is as well. Of there are endless applications for the properties you get for data just by putting it on a blockchain. The immutability aspect is great for posterity of data. I really like that you bring identity into it, because that's a really nice use case where you can actually minimize the cost. You don't necessarily want to publish large amounts of raw data, but you want to make attestations. You want to hash something or encrypt something on the chain that you can then use to prove later. So I think that's a really good application that you mentioned.
Yeah, I mean, they all tend to be small amounts of data only, a URL, a hash, things like that. There are chains out there where you can put more data on them. I wrote an NFT contract for the Binance Smart Chain back in 2017 that put images on the actual chain just to see how it could be done. I had to come up with a neat compression algorithm and get PNGs on there. Learned more about data formats for bitmaps and PNGs than I ever really wanted to know. And of course, as time goes on, the data storage will get cheaper. I mean, this is one of the things I find really funny is how I remember in 2015, 2016, people saying, oh, the chain's going to get too big. Have you seen the size of Bitcoin? It's going to be a terabyte by the end of the decade. And it's like, well, I've got 4 terabytes of solid state drives in my computer here. And I think I paid under $200 for them. So I'm sorted for the next decade.
Yeah, I think Bitcoin is a bad example, right? The amount of data they're actually pushing is so small, especially compared to some of the networks that are coming out now.
But people were worried about that. People were worried that the small amount of data that Bitcoin had in 2015, it was a serious discussion. What can we do to keep the chain size down? Because we're talking about hundreds of gigabytes and home computers can't handle it. Now it's 2025 and home computers are outstripping Bitcoin, no problem. Nobody's worried about that anymore. You're right that there are other chains. I mean, Ethereum takes stupidly long to synchronize. I run a Bitcoin node at home. I don't run an Ethereum node because it just, if I'm going to run one, I'd like to run a full one, not one of the cut down lightweight ones. And it just takes I can't keep up. It's I don't have a fast enough network connection, even with 5G, and I can't buy an SSD that's big enough. I have to RAID several together. So it's kind of like, well, I'll wait until hopefully computer hardware will overtake the Ethereum requirements as well. But then there'll be the next chain that is even bigger. So
yeah, well, I guess this kind of comes down to the idea of like the immutability with storing data on chain. Like, should there be future costs associated with that? You put this image back in 2017, and there are miners probably who are still maintaining that and storing that somewhere. And I've seen like more and more people are talking about the idea of pruning, data that's not used and having these special archive nodes that cost more to retrieve that data. What do you kind of think about that?
Well, I think these are kind of they're always short-term problems. They seem significant, and then later they become irrelevant. So one thing you could say is, yeah, okay, I may have put a lot of data on Ethereum 8 years ago, and it's still there now. The fact is, I had a lost opportunity because I spent Ether on it when it was like $10 or $50 per ETH. And now, if I'd instead of putting that data on, I'd held the ETH, I would have a lot more money. So in a sense, you are being, as long as the price is going up, you are being retrospectively charged. And who knows, maybe in some point in the future, they will go through and discard stuff. But it's difficult because how can you tell what's significant and what isn't? Right? And just because nobody has called a smart contract in 10 years doesn't mean that 10 years from now it's not going to be important.
Yeah, 100%. I mean, there's part of what we said about, just putting things out there on the blockchain, and then because you have this value transfer value component embedded in everything, you kind of immediately test it in a marketplace, right? You find out if these ideas are good or if they're bad, and that's why you see some projects taking off, some smart contracts taking a lot of adoption, even when the costs are high. Things like Ethereum, people still use Uniswap despite the kind of exorbitant costs, but it's part of the whole entanglement of the value transfer and the technology, I think. Keir, I'm really curious to get your take on what applications really excite you for smart contracts. So obviously, I believe your background is as a patent attorney, correct? And you're obviously also an inventor. But
well, no, I'm a pro se inventor, so that means I represent myself. I haven't got a patent attorney license. I've never done a formal law course.
Oh wow, okay.
My previous employer had a what I thought at the time was a pretty generous reward scheme for employees who submitted inventions. It's quite common in American tech companies. They give you $400 if you give them an invention, and they give you another 1,000 or 1,500 when a patent's granted. So, so I thought that was fun, and I spent quite a bit of my spare time coming up with ideas, and through that I got to talk to patent attorneys. And because they're paid by the hour, when I asked them questions about why the patent application that they wanted me to look at had strange words like, why did they say, the database comprises A, B, and C? Why don't you say it includes it? And they go, oh, it's a legal thing. And well, can you explain further? And why are the claims? Why do they look like a computer program written in English? So, so I wasted a lot of company time talking to their attorneys and getting a free education in how the patenting system works. And then once I got laid off, I thought, well, I might as well start filing my inventions myself. And then you read articles about how to argue with the examiner about getting it granted. The patent examiners at the patent offices really like talking, well, not all of them, but a lot of them really like talking to inventors who are representing themselves when the inventor seems to be clued up, because it's kind of makes them feel like that was really the point of the patent system, not about arguing legal technicalities, but talking about the invention and why it's significant. And I think I'm at 16 granted patents that I own, that oh no, 15 because I sold one, that I did it all myself, right?
Yeah.
So
you were talking about all the crazy things you can do with smart contracts that you're regularly developing outside of the patents. You were mentioning like whitelists, patent, well, NFT creation, all this kind of stuff. Which of those could you kind of dive into that you find as a really exciting real world application of smart contracts? You were talking about so many different industries, and something like that.
Well, I to me, the obvious one has always been the gaming industry, right? I mean, we've gone through this strange evolution of ownership in that, when I was young, I had my record collection on vinyl and then on CD. I had my book collection on paper, and I had movies on DVD or VHS before that, and I owned them. I had a box, and as long as I looked after them, I knew that I had them for the rest of my life. And then we got to the point where it became easy to duplicate CDs and copy MP3s and stuff like that. So so we used to own our stuff, and not only that, we could lend it to our friends, and we could give it to our kids, right? Then streaming came along and solved the problem that these media companies had, in that they could, rather than trying to solve things with DRM, which didn't work, They could lease us the movie. So even if you go and buy a movie on Amazon Prime, right? You don't own it the way that you owned it when you bought it on a DVD, because when you die, you don't get to pass it on to your kids, right? Plus, you don't know what they. I haven't read the 27 pages or whatever that terms and conditions, but I imagine that it actually says there's no guarantee that you will be able to see your movie that you bought at some point in the future, because it's just too big a promise to make, right? And they have the responsibility to make sure the server's running, whereas when they gave you a DVD, the responsibility was yours to make sure it didn't get scratched or lost or burned in a house fire, right? So and I think that blockchain may allow us to return back to that sort of golden age where you actually bought stuff and then you genuinely owned it, in the sense that it was yours to keep forevermore, or pass on to somebody else. And I presume that'll come with extra costs. They'll keep, streaming cheaper than actually buying it, but you'll have a real representation of it in digital form on a blockchain. And then I mentioned gaming, and the reason I mentioned that is because my kids are obsessed with amassing digital assets on Fortnite, on Roblox, on Brawl Stars, and things like that. And they think that a Pokemon that they own on Pokemon Go on their phone, they give that the same credence they give a Pokemon card, right? So I'm Gen X. To me, the card is certainly more valuable than the representation on the phone. But they live in a world that they have a different view of the digital that I do. For them, the digital is much more real than it is for me. I imagine if they watch The Matrix, they'll just go, yeah, and right. So they're not going to have the kind of mind-blowing experience I had when I watched it. Once I got over the wanting that phone that went click. So, and I think there you may end up in a situation where they want to own their game assets and know that they really own them. That if the game eventually shuts down, they still have the assets that they obtained. And to me, clearly, the blockchain is the way to do that. Right now, we're not relying on a company continuing to run the servers. Now we have decentralized data storage, decentralized blockchain, and other people ensure that it keeps surviving. So, so that to me has always been the first use case. But the game industry didn't like it, so they did a PR hatchet job on blockchain to start with, and they got the gamers thinking that this was going to be bad for them. How genuinely owning your gaming assets could be bad for you as a gamer, I don't know, but it worked until now. Maybe the tide is starting to shift.
Yeah, I certainly hope so as well. We've talked a lot about gaming and the potential for blockchain native digital assets, and I really like how you knitted those two examples of like the big potential future use cases together, because they're kind of two sides of the same coin there, and how you described it. Because I also saw, I just looked it up, the Bruce Willis purported story of suing Apple over being able to give his iTunes library to his kids. And apparently it was not a real story, but everyone knows it. It's one of those.
Everyone knows it.
It's one of those. Yeah, exactly right. It's one of those kind of Mandela effect moments or something. Yeah. Everyone knows that story, but it resonates. That's probably why. Okay, and why is it not possible? As you said, why can't Apple give that guarantee? Well, it's because what's the lifetime of Apple? They're a super company. They're a huge company. But will they outlive most people, especially if you're, under 30 or something right now? And exactly what you just said there, that's one huge distinction with the blockchain is it doesn't need a single entity to keep running. It can keep replacing with the fittest entities, right? It can continue going on by replacing who's running it over time. So I think that's a really, really nice way of explaining
it. And as long as it's providing value, there will be people who will run the nodes. And which I'm not going to make any predictions on how long the Bitcoin chain or the Ethereum chain are going to continue running, but I strongly suspect that they're going to be some of the longest running forms of software that we're going to have. That these things are going to, I think DOS is a fairly long running piece of software, and it's pretty much died now. And there are some Unix libraries that are now continuing in Linux. But I think as a kind of big piece of visible software, the various blockchains that we're seeing just arising now could be around for potentially centuries.
Yeah.
Definitely
insane.
financial advice from Keir, I think. So we best buy Bitcoin, Ethereum before we put this episode out, Jack.
Well, I don't see any reason why not, right? As long as they keep providing value, then and they may die off in the same way that currencies die off, right? Money continues, but every major European country seems to have had a go for a century or so at being the reserve currency until it went over to America. So I don't know which particular ones will die, but I suspect there's what's it called, the Lindy effect, right? Which is the longer that something continues, the longer it is likely to continue. And so, Bitcoin's been around 15 years. It's probably going to be around for another 15. And if it manages that, then it may well last 60. So who knows? If we're all still around as a functioning planet in a couple of hundred years, there could still be that, what was the Satoshi quote at the beginning in the very first block? Chancellor of the Exchequer considering raising rates a second time or something like that. I should know it off by heart, really, but I don't. But it'll be there, right?
Yeah, I think I also subscribe to that idea. I think it will probably be, or at least a couple of the chains we already know will be the longest surviving, things we have in software.
Yeah.
So I think that was a very fair prediction for us to end on. And Keir, it's been such a great conversation. Before we let you go, we do have kind of 2 extra questions at the end. If you're happy for us to ask you, we ask these to everyone because it's quite a bit of fun at the end, and we like to see how the answers.
Well, thanks for the heads up.
No worries. It's I'm sure you're. If anyone's gonna be able to do this off the cuff, I think it'll be you. So the first one is, in one sentence, how would you describe Web3? What does it mean to you?
In one sentence. Okay. Well, I've got a nice little PDF that I produced that explains Web3. So really, what I should do is
throw
just
it
read
into
out.
ChatGPT and
That's
just get
right,
the one-liner.
Yeah. Well, I was going to just say the URL, right? Provide a pointer to it. I think it's the fact is that Web 2 is websites with databases where the databases are controlled by the company, so Facebook or LinkedIn or Google or whatever, and you or I can change stuff in them with permission, right? And Web3 I see as now we have a kind of back-end data store where we as individuals get to set the rules as to how that is altered. And then you can go on and one of the uses for that decentralized data store is that you can use it for value, which is what people focus on. They say, oh, Web3 is the internet of value. Well, I think it's a lot deeper than that. But the first surface application is you can then use the database that everybody can access for keeping track of who owns what. Later, I think there's going to be a load of other things. I mean, I spent some time with a guy I know from LinkedIn looking into if we deploy websites on the IPFS and we use the blockchain as the data store, because you see you have this problem if you have a decentralized website, which is where do you write the data that people are putting into it? Otherwise, it just becomes a static site. It's not exciting. Yeah. And the answer is it can write it to the blockchain, except for one thing, which is that it has to go through Infura or Alchemy. It has to go through a node. So once everybody has the blockchain node in their browser, then it does. You truly have the possibility of fully decentralized websites that you just push out there and forget about. And if they're popular, they survive. And if they're not popular, they disappear.
Yeah, I love that description. And I love that idea as well of blockchain, effectively blockchain hosted website content. I was hinting earlier about like the Internet Archive. I think it's a great application. And when I asked that question about one sentence, I was thinking of just saying it's redundant because you have that brilliant PDF. It's probably one of the most shared PDFs after the white paper in all of Web3 and crypto.
It's certainly very popular.
Yeah, because it is so succinct. So we will definitely link that in the episode show notes. Don't worry, and we'll definitely share it because I personally love it as well. Okay, and the final question, Keir, then is, I sound a little bit like I'm doing a political interview now. That was weird. I'm going to do one of the debates.
I refer the
Not
honourable
not Emily
gentleman to the
Maitlis.
answer I previously gave.
Oh wow, I knew we were going to get politics in it somewhere. Anyway, so if you could pick one person from throughout history on the planet with us today, or could even be someone fictional, to sit down and talk about all these things, Web3, smart contracts with, who would you pick and why?
John von Neumann.
Okay.
Right. So he's the Hungarian mathematician who went over to the US and worked on the Manhattan Project and was a lecturer there in mathematics. And I mean, immensely smart, one of the smartest people that's ever lived on the planet, but capable of talking to ordinary people. And I think, I mean, he just, when you look at the conversations he had with people like Claude Shannon, the father of information theory, and Richard Feynman and Norbert Wiener and people like that, I mean, he just seemed to be able to talk to anybody about anything. And I think he would have been fascinated to see blockchain. Plus, I went to visit his birthplace when I went to Budapest to see. My wife gave me a long weekend off from the kids. Said go to Hungary, go and do fun things in Budapest. And I went and stalked dead mathematicians' birthplaces, John von Neumann and Paul Erdős, two sort of personal heroes of mine. She was very disappointed.
I love that answer. It's definitely, we've not had that answer before, I can tell you that. But yeah, I definitely agree with that. Like, who was it, Feynman, who said if you can't explain something to a 6-year-old, then you don't really understand it yourself. So yeah, I think a real show of intelligence is being able to explain things simply to people that don't necessarily understand the topics. That's a great answer. Thank you, Keir. Like, this has been such a great episode. You've explained so much in such layman terms, and I've learned a lot. So thank you for that. And I hope we get you on the show again. And all that's left to say is thank you to those listening wherever you may be, and join us next time to untangle a little more of Web3.